recording. So first of all, I would like to welcome everyone to today's this morning program. So first of all, welcome to the School of Physics, although we are streaming from our own houses. My name is Nurul Hashikin. I am a lecturer in medical physics from the School of Physics. So I'm representing the Medical Physics and Radiation Science group. So today we have a distinguished speaker, which is my former supervisor from the University of Malaya when I did my PhD. So before that, the attendance today is, we have wider attendance from people outside the field as well. So before we start, just a little bit introduction, for you to get the idea of what medical physics is. So basically, medical physics is a branch, just generally what my own interpretation of what medical physics is. Medical physics is a branch of physics that involves that investigate or focused on the application of radiation, be it ionizing or non-ionizing, for the purpose of diagnostic, which is for us to investigate whether the patients have a disease or to investigate the extent of the disease, and also for the purpose of treatment, especially in the treatment of cancer, especially, but not limited to. So today we have a distinguished speaker, which is Professor Dr. Kwan Hoong, who needed no introduction, I suppose. So yeah, as a former student, I feel like when I come to USM, I needed to share and introduce him to my colleagues and my students, and just to pay homage to my supervisor, PhD supervisor, or I always thought him as my mentor. Hence today, the intention of why I did this program. So without further ado, let's watch a video. I want to show you a video before we start, just to show. Okay, wait. Okay, this one. Wait, sharing screen. Let's watch a video from first before we start.
Hi, I'm Professor Kwan Hoong from the University of Malaya. I'm the recipient of the Merdeka Award 2020 under the category of Outstanding Scholastic Achievement. It was a pleasant surprise for me when I received a call from the Merdeka Award office and kept asking the lady, Are you sure you got the right person? It was a very humbling experience. But there are so many great Malaysian scholars that contribute much more than I do. Anyway, I told my dear wife, Ms. Wan, straight away about this great news. And I thank God, also my late parents for guiding me and bringing me up. When I was small, I was interested in science. So I studied at secondary school and the universities. My interest and passion for science grew further when I chose medical physics for my postgraduate study. It was a very new field in Malaysia then, and particularly when I started to collaborate with different people around the world and see the result benefit the patients. And it was very gratifying when I collaborated with various scientists and doctors around the world, and our work is pretty well recognized and appreciated by all. When you see how the research is benefited on patients and improving the healthcare, and this has spurred me to continue to do more research and also to train more graduate students. And I go by my personal philosophy that of humility, gratitude, and charity, and this have helped me a lot in achieving greater heights, knowing that what I've been doing will be for the good of humanity. It got to be the very prestigious Marie Skłodowska Curie Award given by the International Organization for Medical Physics, the IOMP. I received the award at the World Congress in Prague in 2018. It is special and memorable for me because I'm the only and the first scientist from a neighboring country to receive an award. It recognizes one's contribution, achievement in scientific research, in his contribution in education, as well as leadership in stimulating professional growth. My wish and advice to young Malaysians is to set your eyes on your aspirations. With it, you want to be a scientist, a teacher, an artist, or a doctor. And knowing that the path will be turbulent and treacherous. So be very courageous to face all these obstacles, criticisms, and negative thoughts. And remember, it's only with perseverance you will succeed. Whatever that you do, remember to be a person of integrity. And always be thankful to those who have helped us in our life.
Okay, so that's just a little bit of introduction, just to keep you intrigued of if you haven't know Prof. Ng already. So we are also privileged today to have our Vice Chancellor to actually come to attend this talk. So we have Prof. Rafiq here with us. So before we start, if possible, Prof. Rafiq, if you want to say any few words to Prof. Ng before we start.
Okay, thank you, Dr. Shiki. I thought people did not realize that I'm online. I joined this at the personal invitation of our esteemed professor himself. Again, let me, I was probably one of the first to congratulate him for his Merdeka Award. And although we've not worked directly together when I was in but we did cross paths a few times. Prof, thank you so much for gracing this event. The Merdeka Award clip was super inspiring. I feel very inspired already, and I'm sure everyone would like to know more, to hear more of your wisdom and insights into, what makes super scientists like yourself. Again, thank you so much, and I hope everyone would have a good webinar. I might not be able to stay until the end, but yeah, it's such a privilege to be here. Thank you, and thank you for the invitation, Prof.
Thank you, Prof.
Okay,
Rafiq.
thank you.
Just a few words. It really brings back good memory, Prof. Rafiq, when you were the Deputy Vice Chancellor, giving you suggestions how to improve the environment of the campus. And in that way, we did work for a couple of years. You see the improvement in the campus, environmental friendly, particular, and all the wonderful things. Whenever we received the alert, the KL gate, the river or the stream flooded, we got this alert in the email, and we always think of you as the one who got it started. And thank you very much also for the congratulatory note from my Merdeka Award last year. Okay, over to you, Nurul.
Okay, Prof. So thank you, Prof. Rafiq, for the kind words. So before we start, just a little bit of just reminder, like introduction, who Prof. Ng is. So before I give to him to present his slides. So Prof. Ng is currently a professor at the Department of Biomedical Imaging, Faculty of Medicine, University of Malaya. So he received his Master in Medical Physics from the University of Aberdeen and Ph.D. In Medical Physics from UM. He is a certified medical physicist by the American Board of Medical Physics and was a visiting scientist at the University of Wisconsin. In terms of consultation, among other things that he is doing, he also consults for the IAEA, which is the International Atomic Energy Agency. in radiation safety, dosimetry, and quality control in radiology. And he was also a member of the IAEA comprehensive study team that is working on the 2011 Fukushima Dai-ichi nuclear power plant disaster, if you still remember. And in terms of research, Prof. Ng has authored and co-authored over 200 papers in peer-reviewed journals, 30 book chapters, and co-edited 8 books. So his main contributions are in radiological protection, radiation dosimetry, risk communication, biophysical characterization of breast disease, and also quantification of breast density. And among excellent things that he has achieved, Prof. Ng's research effort has led to the publication in the Lancet Oncology, which is a journal with very high impact factor, 33.7, which is very high. So this paper emphasized on the standardization of breast density measurement that will have significant impact on improving the predictability of breast cancer research. So the award and recognition that he has received in 2013, Prof. Ng was honored as one of the top 50 medical physicists in the world by the IOMP, which is the International Organization for Medical Physics, alongside famous names like Godfrey Hounsfield, which is the CT scan inventor, Herbert Ethics, which, you know, the famous dosimetry books, and also Peter Mansfield, the inventor of MRI, among other names. So in 2018, he received the Marie Skłodowska Curie Award given by the IOMP for his excellent contribution to research, education, and leadership. And recently, which is last year, he received the Merdeka Award for Outstanding Scholastic Achievement. So yeah, so let's give the floor to Prof. Ng. So Prof, I give you the sharing privilege now. Wait, yeah, Prof. Presenter. Okay, Prof, the floor is with you.
Do you see my screen, full screen?
Yeah, but it's lagging. Wait, Prof. It's still black.
Lagging.
Okay, I can see now. Make it full screen, Prof.
Okay. Belum.
Yeah, can you make it full screen?
Now?
Okay, Prof. So
Okay,
take your time.
Okay, selamat pagi, salam sejahtera, and good morning. First, thanks to the USM for inviting me. Particularly, I'm very honored to have the Vice Chancellor himself attending my talk. And thanks to my one of the best PhD students I had, Dr. Nurul Hashikin, a very wonderful, hardworking student then. I'm sure she is hardworking lecturer. I chosen this talk on succeeding in medical physics for the good of humankind. And you can replace the medical physics by other disciplines as well, engineering, maths, biology, physiology. You can extend that. I hope I can inspire many other people away from the medical physics to join us. I was looking forward to this. Do you know where is this place? I was supposed to go physically to USM. Unfortunately, the lockdown started March last year. Else, I'll be in this place. One of my favorite places, up in the hill, Bukit Bendera, Penang Hill. Looking for adventure, excitement. Never found any dinosaur there. So our journey in life, as well as in academics or research, is a long journey, and often it is not smooth. It is uphill, many steps, full of loopholes, obstacles, and this is what I would like to share with you, my experience, particularly the students out there listening, undergraduate or postgraduate in physics or others. What is my future? what could I do after my graduation? What research can I do? Well, what is medical physics? When I started 33 years ago, it was very new, and it is still new. Though I work in the hospital in the Faculty of Medicine for 32 years, still there are many doctors that don't know, hey, medical physicists, what are you doing here? So we bridge between physics and engineering, right? Physics covers engineering and maths as well, and with medicine. So we try to come together to meet, see how we can contribute to that. So this, we try and try again to come together, to engage with the medical professionals. Medical physics is a unique field. Unlike, for example, you're just doing physics or chem or maths, it is both a profession and a science. Profession, many of our colleagues, they work in the hospitals, in radiology, oncology, nuclear medicine, and others. So it's a clinical-based profession that is a service. On the other hand, you also have the science component involved in academic, in teaching and research. So that is unique. So some of us have more emphasis on the academic and less on clinical. But however, the most successful, who contribute the more impact to society, will be a combination of both. So for example, I'm an academic, I'm a professor, but I still do my clinical work in the hospital to teach the medical officers in radiology and oncology, impart as well. So, and beside that, research and teaching, some of us involved in administration as well as we progress in a career. So medical physics has been playing an important role in the development of new technologies that have revolutionized the way medicine is practiced today. You look at almost every field, you find whenever there is the technological improvement, there's always the input from the scientists. In this talk, I want to emphasize more on the medical physics. And it's from different disciplines as well in research to improve the quality of life of patients. And medical physics is such that it's interesting. In a while back, I wrote an editorial, Medical Physics in the 2020. Will we still be relevant? It is important. I gave this talk as the John Cameron Memorial Lecture 2007. 2020 had passed. Yes, we're still relevant to healthcare, to the society. And in order to stay relevant, it is important that we look at the picture here. You might know about this story, Who Moved My Cheese? Those in management, those in the business who definitely know about this. It's a very interesting book by Spencer Johnson. So instead of going around in the maze looking what we call like cherry makan, and you see that the cheese is so rotten, it is no use. We think out of the box, right? Like this. Now just move up the pole and use the telescope, look far, look for the cheese further away somewhere else. So hope you can get the morale of this story. And that is important to be relevant, particularly the world today is changing so fast, it's so competitive. And this is exactly what Charles Darwin said. It's not the strongest of the species that survive, nor the most intelligent that survive. it is the one that is most adaptable to change. Adaptable, it is important. You look at Darwin's theory and always about adaptable. And we know about that COVID-19, the virus keep on mutating, adapting to the new environment. So as humans, we are much more intelligent. We need to be more adaptable to change to solve the problem. As I mentioned, we are competitive. The world is changing so fast. We hear about the molecular revolution. Everything is about the molecular biology, molecular medicine, and also artificial intelligence. AI is a buzzword in almost every discipline in our everyday life. We can't avoid that. So are we prepared to contribute to this? So there are a lot of new technologies, like nanotechnology, drug discovery, preclinical imaging, or we call it also the animal-based imaging, optical imaging, bioinformatics, and today you have this quantum computing coming soon. So are we prepared to explore these new technologies? So that's very important that in this way of research. The medical physics by itself is interdisciplinary. Those who come from a physics engineering background will really have to study anatomy, physiology, biochemistry, and all that medical stuff, along with their knowledge in mathematics, computing, and many they learn along the way, and understanding the other disciplines in order to innovate. That is important. So it is not just only we enhance a specific skill and competency, but we also need to look into the future to equip ourselves with this new knowledge being developed. So it is challenging. So that calls the question, the future existence of medical physics. And our colleagues in the developing world, in the United States, in Europe, they are preparing, they call it medical physics 3.0, moving to 4.0. Just like in Malaysia, we have the Industrial Revolution 4.0. So preparing for the future. I'd like to go back to my mentor, the late Professor John Cameron, when I spent some time in the University of Wisconsin in the United States. And University of Wisconsin is a great place, lots of great people, and 8 Nobel laureates from there. And Professor John Cameron was an inventor extraordinary. Remember the bone densitometry, the DEXA scan, that is common. Well, he is one of the co-inventors of that. Also, you know about the TLD, the thermoluminescent dosimeter, and that it was the one who brought from the physics and chemistry to the clinical world to be established as a clinical dosimetry. And also the various quality control devices. So these are some of his contributions to medical physics and to medicine. Now, one of the important quote I like to always mention to my students, if anything is worth doing, it is worth doing it badly. He was citing G.K. Chesterton, a very well-known philosopher, also novelist from the UK. Why doing badly? Strange. What it means, it doesn't have to be perfect, just get it to work. You look at the symbol, the young one will know, right? You have the Nike shoes, the slogan, just do it. The Nike, just do it. So often that itself will spur the students, just do it. Don't worry about perfection. Don't say, oh, Yeah, it's not accurate enough. Let me fine tune a bit before I do the experiment. Maybe you want more precision to your result. You want something looks nice. But don't worry, perfection could always come later, right? If necessary. Just get it doing first. And that is a very important attitude for the students. It's a human tendency. We procrastinate. And then mind tomorrow or next week, right? Don't procrastinate. Just do it. Oh, remember Yoda. Do or do not. There's no trial. Okay? That is important. Of course, in his circumstance, there was galactic war going on, life and death. We can think of our journey, and for those of you who are studying, or those of you who are in the academic lecturing, that is important to optimize our time and our talents for the betterment of humankind. Let's talk about some of my research. Nurul introduced a bit. My main focus has been breast cancer towards personalized medicine. Nonetheless, I was expanded from breast to other systems and organs such as the kidney, as one example, the bone marrow, and many, the heart. So you can see me here doing some of my research at the mammography system, right, for the mammogram. The emphasis today is the diagnosis of disease, right? Mammogram, CT scan, MRI, and then treatment, particularly in our area, is radiation therapy or radiation oncology. But you can go beyond that, from diagnosis, go to prevention, to prediction. And this is where we, along with other disciplines, could contribute more. There is a lot of work needing to be done. Prevention of diseases and prediction. This is where AI comes in, and big data analytics. The other end, after diagnosis, if early diagnosis is a better cure in therapy, in prognosis, so to manage the treatment and monitoring so that we see if the therapy is effective, is patient improving, could be changed a different form of therapy, and so on. When I say therapy, here includes different forms of therapy, not necessarily radiation, it could mean chemo and physical therapy, and lots of modalities we have today. And Nurul mentioned that this Lancet Oncology, yes, it is a very prestigious to get into one of the Lancet's journal. Published this along with two breast surgeons, Prof. Aisha and Prof. Yip, April 2012, and that so lay the foundation for standardization. Now, my main contribution is breast density. That's the amount of granular tissue in the breast, and this is an indication of the risk to having a breast cancer. So the higher content of the granular tissue in the breast, we call it high breast density, means that the chance of that lady having cancer is higher. So you need to quantify that, and also using it along with other biomarkers to have a much more accurate prediction. So we need to standardize it, and this is important in terms of the technical parameters to acquire the mammogram. And that led to one of my best publications, invited by medical physics. And this is in a profession, it is the premier journal, the very top journal that every medical physicist hopes to publish at least one in his or her lifetime. And this is a dream that encourage you out there to consider publishing. So this is Vision 2020. They invite opinion leader, the pioneer in the field, to write about that. In this case, it's mammographic breast density and its clinical application. So laying the path and the future direction where this research is going. So point to the next 20 years, what are the new areas, new research we can embark on? And that is one of the major contributions. So these are some of my research topics. I'll be happy to share with you more later. Early days of my career, I did a lot with radiation dosimetry, landed me with my consultancy work with the International Atomic Energy Agency, the IAEA, and also risk communication as well, that started with Fukushima and until today with the COVID-19 pandemic. So this is my quote and unquote. Because breast density can be altered, breast density can be altered too. So the breast destiny, the future of the breast, meaning the breast health. Hopefully we keep it healthy, can be altered, can be changed. Indeed, there are some factors we can change the density from higher to lower. Some of these will be chemo intervention, certain drugs, lifestyles is important, right? More and more people are very sedentary sitting, so we encourage exercise, eat healthy food, and this will contribute to a healthier breast and also healthier body, mind. Not necessarily breast, could be lung, liver, and others as well. And it is important. So we continue to work on this area along with different disciplines, with the breast surgeons, with epidemiologists, with the biologists as well. And I also involved in my career publishing many books. These are some of my key publications. The first one on this subject dose. People talk about patient dose a lot, talking about diagnostic reference level. That we started this along with Professor David Bradley. He happened to be USM long ago, one of the early pioneers of the physics group in the USM. I working with him then. That was books more than 20 years old. It's one of the core book around. And also this involved in the effective medical writing. So also with Professor Wilfred Pei from Singapore Medical Journal. And also you have the radiology safety and quality. And at the bottom, the various journals I've been involved in the editorial board or deputy editors. There's some about 12 journals and also various publications from the IAEA textbook and others. So it is important for scientists, for medical physicists to do research and to write, to publish. It is important. Journal papers, book chapters, monograph, and many others. So this is the taken just before lockdown. Was in the IAEA in Vienna, in Austria, the headquarters. I've been involved in the IAEA for some 20 years as an expert, as a consultant. And the recent one was in Fukushima, when the disaster erupted in 2011. And 2 years later was grouping. They have a huge international task force to look into the Fukushima. So I was in task force number 4, look into the radiological consequences of the Fukushima disaster. And later, the radiological expanded to the consequences could be socio-economic, could be the mental state, beside the radiological impact in Japan and the whole world. So I have a chance to visit Japan with the group at least once a year. We've been to Fukushima itself. We have to different cities like in Tokyo, in Nagasaki, and other places. So we interact with the local scientists, international scientists. Interesting. So I was working in particular with risk communication. Now, most people won't understand the radiation effect, radiation risk. So this is where scientists like us come in, how to really explain this in the layman's term. How much risk is there? How would it affect the life of the common people? They want people to know, is it safe for me to live around the nuclear power reactor? And particularly now, Japan is going to release the treated water to the ocean, and that has created another round of international fear and panic. So I'm involved in some research in this risk communication and look at the media, how they convey this. So also working with the media people, with the linguistic people, and see how the newspaper and the social media portray this kind of news. So the bottom you can see it was in Fukushima prefecture itself, those buildings being affected by the tsunami earthquake. And the left bottom, you see, they have a lot of radiation monitors all over the country. In fact, train stations, schools, bus station, hospital. So you can see the real-time radiation level. So elevate fear. And professionally also was involved in founding the Southeast Asia, the CFORM, Federation Organization of Medical Physics. The top is the fathers, mothers, grandfathers, grandmother, some 21, the AIOMP, of Medical Physics, which again I initiated the photograph second in Vietnam. So we continue to have the professional organization in the region, in Southeast Asia, to promote medical physics in research, education, training, and professional activities. So encourage you all, particularly the AIOMP, we organize also workshops, and there's one coming up in Phuket, October, the CCOM. I'm organizing workshops on the artificial intelligence in medicine. So do participate. Okay, let me now go to a couple of areas, research and innovate. And there is a huge area with modern technologies. And top, you can printed a scarf from the 3D printer. This is one of my PhD's work some 5-6 years ago. So we have lots of innovation from the 3D printing process. We can do lots of things, and various imaging in therapy as well. Now, what research should I do, or what research could I do? I'm sure many of you are looking for topics, area can do, students, lecturers alike. Hopefully, some of this will give you some ideas you can go into. Lots of interesting, exciting areas like nanotechnology, material science, the magnetic detectors, particularly the tiny detectors, biodetectors, various sources, proactive service. The sources could be radioactive source, could be energy source. So these are technologies that are pretty mature now. So how we can tap into the application in the clinical, in cancer, in stroke, cardiovascular disease, even bloodless interventions. This is where we come in, utilizing robotics, for example, and all these tiny detectors we can be introduced into the body. And decision support is all the computer-based system. And the next generation, well, you could say we're already here. This next generation is starting. We're at the beginning, proactive health, and some call it precision medicine, large molecules, and we talk about also that for the vaccines, for the COVID-19, right? There's a lot of interesting work there, chemistry, biology, and remote access using cloud computing, and even today, we are using the internet technology for our meetings. And I created this a couple of years ago, saying physics engineering in medicine. Those out there are looking for research collaboration. Look into this. Make friends with those in biology, engineering, maths. It is so important. And also we need to learn. For example, I have been learning molecular biology, understanding, so that I can talk sensibly with the oncologists, with the biologists, so that how we can work together using molecular biology principle, in particular in nuclear medicine, theranostic. So these are some of the frontier areas we could embark on, we can explore. And those of you who might be thinking, oh, what's the use of learning quantum mechanics, optics? My clinical work, if you work in a hospital or research, but don't throw away this knowledge yet. It will be useful. In particular, quantum mechanics, as most of you, I'm sure, in medical physics, you learn something about in MRI, you need quantum mechanics. It's about, oh, of course, now your proton therapy and this heavy particle, heavy ion therapy, we need to bring back quantum mechanics. But today, the quantum computing will come. The quantum computer will, if you want to know something, want to do something with it, we need to go back to the quantum mechanics. So don't throw away your notes yet and start revising your knowledge of quantum mechanics. Number two, collaborate with other specialties. And this is important. Though physics is our core, this is our foundation, or could be engineering, some physicists background. So other sciences like chemistry, biology, mathematics, computer science, we need to discuss with them, to engage with them, to collaborate with them. And the traditional, we work in radiology, nuclear medicine, radiation oncology, but go beyond that in surgery, cardiology, neurology, physiology. And don't forget, it is important to, and this is something quite new, work with the social sciences, the arts and humanities. For example, I work in risk communication, takes me to work with the social sciences, social scientists, the linguists as well, to understand how our message, our science communication, how does it affect common people, and how would the science and technology influence the society, and that is very, very important. And so much so that in the NUS, they started a new college called faculty, interesting, to combine science and humanities, called digital humanities. And they're just starting the first intake this year. This shows this is how we should be going. So think beyond our areas. So mentioned, we might know something, but explore further. Molecular biology is one, definitely we need to embark on it. And we are going to introduce more components of molecular biology in the master program in medical physics. And that is very important. Cross-fertilization. We just don't want just medical physicists talking among ourselves. We need to go beyond that. Have tea, coffee with colleagues from other schools, other faculties, other departments. And this is important. So I often have so-called lepak or have tea with interesting people in the medical faculty, with the surgeons, with the geriatricians, nephrologists. But beyond that, I also visit the Faculty of Arts and Social Science, Linguistic, to interact with their lecturers, to learn from them. Number 3, develop soft skills. And that is important. Often the employers who say scientists, engineers are hopeless in communication. They don't know how to talk to people. They don't know how to present themselves. So that's important. Often we lack that. So we focus too much on knowledge, on the competency of skills, but we need to know to develop the interpersonal skills in public speaking, time management, conflict resolution is important, and to develop the team spirit, the self-motivation, the lifelong learning, we need self-motivation, and empathy is important. To have the feeling, the heart for other people, people who are less fortunate as us, people who may not grasp our thinking. And all these are all towards the very positive and proactive attitude. So it's good that we take opportunities to develop. I'm sure like USM also has been organizing many courses on leadership skills, and on many this workshop is all helping us to develop all the important soft skills. So much so that we should be able to participate in intelligent discussion with our clinical colleagues, including the nurses, technology. It is important. We need to understand the language as well. So are we relevant or could confidently contribute meaningful to the healthcare and the society? And that is one of the ways we could do that. And finally, communicate, communicate, and communicate. The effective communication is important. You were successful in research. Today, research is not just doing work in the lab, writing a few papers. We need to be impactful. How we can impact the society, and that is so important. So if we want people to know what we do, in the journals, a few may probably read that, those in the same field, same interest, but by and large, the members of public, the funders, they may not have a chance to read. So we need to communicate. It's so important. And today, all of us make use of the social media. So could we take advantage of that for the wider audience to communicate with them on what we do? Now, that leads to we need to learn how to communicate effectively with members of public. So I have taken up a couple of courses myself, learned from the journalists, the linguists on communication. So in my career, I've been engaging with the public, the conventional media, the newspapers in various languages. On the right, this is my colleague from Nepal, a small country, and they're also concerned about all this nuclear because they're surrounded by the nuclear states, India, Pakistan, and China. So they're also worried about what is this nuclear, about uranium. So he was also giving talks, educate the politicians, the journalists, the public as well. And recently, interesting, I like this caricature, the Malay medium newspaper, right? Jangan sorok makhluk mat. I really like the caricature, fantastic artist. So people always think the stereotype of medical physics, okay, you measure radiation, you carry a gigamolar tube. It's more than that, right? So we're really trying to explain to people we do more than that. At the bottom, it is with Prof. Hamdi, the Vice Chancellor. It was congratulating me on my Merdeka Award. By the way, the official ceremony, I'm supposed to receive the award from Tuanku, Sultan of Perak, but the ceremony has been delayed many times. So it is really not officially receiving the award from Tuanku. Last time to show about nurturing our next generations of medical physics leaders. Like we grow a plant from seedling, we need sunshine, fertilizer, water, rain. This is important. All of us who are in the lecturers, we are leaders. We also need to nurture the next generation leaders. So who are still young, energetic, very dedicated, passionate, to enable the future. It is important. But we also need mentors. So to guide them, to inspire and to nurture them. It is so important to mentor them. And this is why I started interesting. I met various people. I've been visiting professors also with the IAEA to various countries to teach, to give talks. And the talk was in Brazil, in the University of Sao Paulo, a very established physics department. Fantastic, a lot of fantastic work they do in Brazil, one of a very strong country with a very strong science, manpower, human power. I met many of their graduate students. At the bottom, they met the Indonesian students as well. So many are very keen, but they need to be nurtured, to be mentored. So I started this global leadership and mentoring program. It started physically and now is virtually. On the top, I have the other colleagues. Next to me is from University of Wisconsin. Next to that will be Prof. Thomas Krohn from Australia and Prof. Eva Bizak from Australia as well. So they were with me when I started this mentoring program. So the bottom are the early mentors to have expanded. So we're covering from Latin America to Africa, Europe, and Asia, Southeast Asia as well. So there's an article you can read in the physics world. Global mentoring scheme fosters future leaders in medical physics. Could Nurul show the cast?
Okay, wait, Prof.
Nurul. Okay.
Yeah. But when I share, I'm taking your sharing privilege, so I will share first.
Hi, Hamish. Now, Tammy, you've been looking into mentoring this week, and specifically a global mentoring scheme for early career medical physicists.
Okay.
Can you tell us a bit more about this program?
Okay, so do you want this? Do you want me to play the video?
Okay. Yeah, you do it now since you are there. Yeah. The podcast. Yes.
Okay.
Okay, so this is a global mentoring program set up by Kwan Hoong, who's a medical physicist at the University of Malaya. Now, medical physics has got its own really specific challenges because it bridges both science and healthcare environments. So the trainees have got to learn to work and research and interact with many different types of professionals in a complex hospital environment. So Ing hoped that the mentoring scheme could provide young medical physicists with guidance and support to help them progress their career, and in particular to help them develop leadership skills.
And so how does the mentoring scheme work? What's special about this particular scheme?
Okay, so they set it up so there was one permanent mentor plus additional mentors from various countries and institutions who took part in discussions and provided advice. The initial group of mentees was made up of 16 people. So this is medical physicists, postgraduate students, plus an early career researcher from countries in Latin America and Asia. And then to establish relationships between the mentors and the mentees from all these different places and countries, the program used e-mentoring, which is basically video meetings, online group conference calls. So basically the things we're all using now. But this approach is particularly useful to support people in developing countries, perhaps where medical physics is just starting up and there's a lack of experienced people to guide these early career medical physicists.
And so how did it go? Is the program a success?
Yeah, so the program started in 2017 and ran until this year. And then the team has just published a research paper documenting their experiences. So at the end of the program, all of the mentees were asked to fill in an online survey, and over 80% of them said the program had had a positive impact on their personal and professional lives, and said they gained knowledge and skills from the mentors. So some of the positive aspects that they described included things like increased self-confidence and less anxiety about moving to new career stages, learning to handle international meetings, improving leadership skills, and gaining a global view of medical physics. It also gave them a way to seek professional advice and learn from each other, with over half of the mentees formed research collaborations with themselves and the mentors, for example, publishing work together. Overall, the conclusion was they definitely recommended that mentoring should be implemented as an extracurricular activity wherever possible.
Wow, that sounds really useful both for the mentor and the mentee. Is the scheme continuing?
Yeah, definitely. So the team plans to expand and diversify the group with getting medical physicists from other continents to join in. So they're looking at people from Africa and from Europe. And what was interesting was that most of the mentees, so over 80%, said that they had a goal of becoming a future leader and they wanted to carry on participating in the program. So perhaps it will be self-perpetuating, with mentees turning into mentors and helping to coordinate activities in the future.
Wow, that sounds like a fantastic program. You can read more about this in an article that Tammy has written for the Physics World website.
Okay, Prof,
Okay,
I'm
thank
sharing
you.
back sharing privilege to you with
Thank you.
yeah.
So that
So I give
podcast
wait, the slide is
from
okay.
Hmm.
I'm
So do I
giving
have to
back
go
your
back
sharing
to
privilege.
share? Oh, I have to,
Yeah.
to click the share again. Huh? Hmm.
Yes.
Is it my... Oh,
Okay, Prof.
can you? Okay, good.
Yeah. Okay.
So you can read about that from the Physics World. Most of these are open access, so even the podcast is quite giving an idea. So we do have regular, beside our mentor-mentee meeting, we always get someone to talk about different topics. We also have non-scientists to talk about, like there's one about for early career scientists. So look out for the announcement. You can join for the next one. Early July, we have one session coming on. Okay, we do open that to the non-mentees of the group as well. So, how do I move forward?
You should make full screen. I think this one is you are sharing your screen. Can you reopen the slide? Is this a slide?
Okay. Yeah. Okay. So encourage the mentees of group. For example, the ladies in the group, they publish this Women in Physics, Pioneers Who Inspired Us. Right? They got together with a little bit of supervision, published this wonderful article. So we hope that next generation, many of you out there, will benefit from that and can contribute to this new world medicine. Right? We are into new world now, new world society, new world everything. Right? So it is with various global health challenges, particularly the COVID-19. We really need our ingenuity, the versatility, right? The adaptable and curiosity of medical physicists and their collaborators from other disciplines. So let's put together our various skills, knowledge, and no purpose. We talk about leaders. So this is drawn by one of the mentees from Latin America. A true leader brings people together, isn't it? Beautifully illustrated. She illustrates herself. So bring people together, different ethnic groups, different disciplines. So we hope that by nurturing, they grow bigger, taller, healthier. And of course, we need the sunshine, water, and fertilizer. This is what we do with one another. We encourage one another so that, well, you sit down and ponder, I know what to do now. So one of my favorite books is Little Prince, Eng Chuang Song Asprey. Beautiful book, small book. Encourage you to read it. As for the future, your task is not to foresee, but to enable it. You don't say, oh, let's see what, to enable, to do it. Uruskan. That's important. Uruskan. Laksanakan. That is important, the message. Don't just think about it, just do something about it. Like this girl said, oh, I'm going to do my PhD in proton therapy as an example. And just lastly, show you some of my achievement. Hope to inspire you, not so much to boast of my achievement, but that was the top 50 medical physicists in the world, 2013, receiving it in Brighton. The conference was held there, 50 years. And there I was in a circle. And along we have a couple Nobel laureates. It's very prestigious here. All the world in metaphysics universities. And the Marie Skłodowska Curie Award was the most memorable, honoring me for the research, education, and leadership that was held in Prague, Czech Republic. And that is a big stage. I give a short speech. What is interesting, our ambassador, Her Excellency Puan Zanaria Zainal Aberdeen, graced the occasion. She came for the award ceremony. So the participants, the organizers were so surprised. Who is this? They call me Kwan, the Prof. That the ambassador from Malaysia attended the award ceremony. And she, a couple of the Malaysian delegates, and my family, and also the Excellency, the ambassador, after the award ceremony. And interesting, it was during the Puasa month. So we had Buka Puasa with the embassy, the family, a reasonable big embassy. and we brought along a rendang. We were so excited, all the way from Malaysia, the rendang and the various goodies from Malaysia. So that is the we uphold the Malaysian spirit, right? We buka puasa along with the embassy family. And also interesting, we had this eminent speaker series. We started in navigating towards a healthy aging. And Tun Mahathir was the guest of honor. Interesting. Of course, it was interesting in aging. So I was involved in the aging research as well. And recently, there is the Merdeka Award, Outstanding Scholastic Achievement, with the Vice Chancellor, Prof. Hamdi. And it's important to be grateful, always be grateful, the gratitude. We thank God for giving us life, our gift, our health, and everything. Our family, friends, our students appreciate help given to us. Could be our lab assistants, could be a cleaner. All these are important. They contribute to our success in life. And send a thank you card. Have you done it before? We often send through WhatsApp, email. A paper card would be useful. Recently, I sent some of the Hari Raya card to some of the old friends, colleagues. They were shocked. Wait, still have cards around. So it's a good tradition to continue and always count on blessings. And here's with my late father and mother, my wife and my daughter. And I like to acknowledge these are my many long-term collaborators over the world in different disciplines. Not all of them are medical, and also the more recent ones from different countries, including social scientists, librarians, surgeons, and others as well. So my personal philosophy, some of you may ask, I mentioned in my Merdeka Award, the commemorative book is Humility, Gratitude, and Charity. Seeing how gratitude is important. And I always want to mention this saying from St. Augustine: humility is the foundation of all the other virtues. And I'm also very thankful to all my PhD graduates, and you recognize the one in the middle, Nurul Hashikin, and from the first one from Dr. Nora Jamal and to others, and also the bottom three, the current PhD students. We have Umi, medical physics. The middle is Chandigra, radiography, and Dr. Nasima for UITM, a radiologist. Notice anything special? It's always lament. I never have a Malaysian male student. The third one from the left, Safari, is Iranian. Wonderful work he did. He's working now in Germany. I never have a Malaysian male PhD student. Most are ladies. And what did I do during COVID-19? As I mentioned, we expand our horizon, we work with people. So I started this people metric trends in research publication. It is like weekly now, is monthly reporting on the publications, highlighting them in science, in humanities, in public policies, and all aspects of in the index journal, so that people have a glance of, oh, what are the recent publications. I work with the bottom various people, including Dr. Ray Kemp from the UK, and the librarians or information scientists. Also work with Prof. Madhya Narizo Adit, one of my former students in biomedical engineering. We developed this Sauna 32, it's a fanciful name for our infrared thermometer, homemade, made in Malaysia. We are going to the IoT new version as well. Especially encourage people to develop things, though it's simple, not a breakthrough. We didn't invent it, we just redesign to prove that you can make it, and to demonstrate to the student, let's do something together, right? Let's make something, let's build up a skill. We need that skill set. Also initiated some research this is my take on collaboration. Contact tracing too. So got the Singapore group, a couple of postdoc from India and China, Australia as well. We published that. It's a very good review. Look at various contact tracing tools and also prediction of the pandemic, the pros and cons, and we recommended one that is the IoT or AI enabled tools. And recently I got a group going with MMU, also someone from USM, Kim, epidemiologist, Hamaru from Kuangkran. I just got it preprint only. Look at the various mathematical modelings and prediction tools. So look at the vice president of MMU, Prof. Ho, computer scientist, and various ones in MMU. Also Prof. Ong, statistician and mathematician. So I just basically got them together. It's important, right? A leader brings people together. We collaborate different skill sets, and this will be very important to highlight, right? The various models being used. What are the drawbacks, and how can we improve on that? So this is how we, regardless of our discipline, right? Though I'm a medical physicist by training, but we look beyond that. Remember the mouse going up, right? There are lots of things we can do, right? Be innovative. And we launched a book March 18, just recently, medical physics during the COVID-19 pandemic. So I round up my collaborators, my international network, my so-called international mafia gang, 91 contributors from 39 countries. It's amazing, right? Difficult to get them together. Also, we cover different regions. They talk about the regions from Latin America, Africa, Europe, Middle East, Asia, and also various how they handle the pandemic, the innovation, a lot of innovation, how they handle the training, education, and how they continue to do some research. So all these are documented in this book, and I roped in Prof. Madalena Stova, Romania. So she's my co-editor. And interesting, we also have a fair representative, 36% are female contributors. So that is good. So these are the various distribution of the collaborating authorships. So bring them together. We work towards solidarity. We need that. And recently, Umi, a current PhD, working on the MRI in Sunday Star, just May 30th. Aspiring medical physicist determined to help save lives. That is in the print version of the Star, but we also have various social media reports of Bernama News and others, and that is very important. Right? She won the one of the 4 winners of the Winter Institute of Medical Physics, alongside with MD Anderson, the very top cancer institutes in the world, in Texas. So we're showing that how, right, though we are from Malaysia, rather limited in terms of resource, but we still can do good work, right? So we need to have the dream. We need to have the determination to persevere. And interestingly, Umi received a lot of attention. It's worthwhile to mention that Her Majesty, the Permaisuri of Negeri Johor, was attracted to her research on thalassemia, and she's sent her a beautiful letter to congratulate her, right, from Permaisuri Johor to Umi. So this serves as a great encouragement for her to work harder, right? Because thalassemia is a big problem affecting many children. Right? So using MR technique, look at the fat content in the bone marrow. So my message to young Malaysians, or to the others, to not too young as well, I mentioned it in my Merdeka Award book. Set your eyes on your aspirations and courageous even if the path is turbulent, adapt to changes, to always be a person of integrity. And find time for creativity will give you respite from worries. Right? Today, always are worried with the lockdown of the pandemic. Even I also have my stress, my worries. So drawing, singing, writing, knitting, or baking, lose yourself in something creative to find inner calm. You might also come up with solutions to problems. This I read it from The Guardian, right? By a writer, Sharon Walker. How true it is, right? Not necessarily scientific activity, something you can do. Like I was indulging, I write children's book as well. A lot of people were surprised. As far as 1985, right? The pengaturan computer logo was in fact, an AI language. It's in Malay, in computer science. It's the pioneer in those days. And Kamus Wibasa Computer, 1991, and a couple of books about the first computer for children, for very young children, and the top for school-going children. So I was indulging in writing, in many of these drawing as well, the graphics in those books. So we see my other side of me as well. So to achieve more, we should imagine together and change. My motto, right? Imagine together, to work together and change, to make a difference. You can contribute to the betterment of humankind or to humanity. And be happy, enjoy our life while we are still healthy, and stay safe. And here I have a chance to be the tall, right? Fantasizing to be the tall. Here I was in Tsinghua University in Taiwan. They have a small nuclear reactor. They talk about thorium. The thorium, the element is from Thor, Thor. Right? So the god thunder. Thank you very much to all of you for listening. Back to you, Nurul.
Okay, Prof. Thank you so much for the very extensive presentation and also very interesting and inspiring. So hopefully this helps all of you to become inspired. If you think that you are currently a bit cloudy, you are unsure whether you are doing things the right way, or maybe you don't know whether you are doing things right, or maybe you are unsure what you want to do next. So hope this helps. So just from the presentation just now, the keywords I would say is from Prof. Just do it. You wouldn't know if you didn't start things. So you should just first of all start, and then later you know lah what the output. So I still remember back when I was your student, Prof. Back in UM. You were not always around because you were always traveling, all over the world, attending meetings and conferences. But whenever you are around, you are always, make time for us, your PhD students, especially on the Friday meetings, to make sure that we are doing okay. So yeah, I also bring that Friday meeting to my own supervision lah. So I usually will meet all of my students on Friday lah. So that actually helps lah. I still remember, and I will always remember that. And I thank you for making me the researcher and the person who I am today lah. So I'm very thankful for that. Thank you, Prof. So
Thank you
now
very much,
I will. Okay, so now we will open the floor for Q&A session. So before that, I would like to remind you, you should wait until around 11:30-ish for you to get a feedback form in order for you to claim your MyCSD or MyCPD for USM student and staff. So for now, we'll open the floor for Q&A. So anyone would like to ask questions to Prof. Just unmute your microphone and then just ask Prof. Thank you.
Can I start? I've got to go soon. Am I allowed to ask Professor
Okay,
a question? Okay, first of all, Dr. Shikin, this is precisely why when I began, I told USM we try to bar formal meetings on Fridays, because we want to have that kind of engagement with our researchers and students as well. I'm not sure how many people are still meeting on Fridays, but this is precisely why we wanted to, we say no meetings on Fridays, not the official ones at least, so that we have engagement. Anyways, Prof, it's very inspiring. Thank you so much. I'm glad I'm here today. All the success that you've mentioned just now, it was, it spanned across what, 30 years of continuous commitment. And there is a term in English that says you gild the lily, in the sense that whenever you are asked to give these sort of talks, you tend to not say anything about how tough it was, and you tend to just focus on the success that they've attained over the years. And of course, you started off as a young academic, just like many of those who are here today. Perhaps my question would be, I'm sure you have lots of setbacks as well across the span of 30 years. Can you share with us perhaps one or two of those setbacks, and how do you actually recover? And the most important thing is to recover from those setbacks. Thank you, Prof.
Thank you, Prof. Yeah. Yes. The first slide I mentioned, the journey is winding road, going uphill steps. And one major for me, I alluded to that, is medical physics is so new in this country. It's just not recognized. So my career was stuck for a while. My promotion was delayed because they don't know what you're doing here, because it's not an established field. So the science community, like faculty science, say, oh, I don't belong to science. When I go to medicine, they say, oh, I'm not the medical. So I'm sort of tossed between the two. So that is difficult. But nonetheless, now the early pioneers have paved the way for your. So it's pretty well known, established in many universities like USM, UKM, UPM, all will have the medical physics. We need a lot of funding for our research in order to do real research or to compete with the developing country, and we lack that. We are lucky. When I started, there's no such thing as all those FRGS, all those. We never have RA, or we did all ourselves, right? Now the lecturers are fortunate. You have RA to do the work. We literally everything, right? From purchasing things to carrying equipment, cleaning up the lab equipment, all this we did it. So there's a very tough time. Also, we didn't have today you have the IT. The search literature is so easy. So we have to go to the library, to back librarian to help us to photocopy or to borrow. Want to refer a paper, it's not easy, right? Those days of print. So that was the hard time, but nonetheless, we make it. Another setback is still continue is that in Malaysia, we still don't have the culture of collaboration. Somehow I sense, I mentioned this to Prof. Hamdi, my VC in as well. We need to encourage more collaboration. We need to trust each other more. Somehow we tend to have a bit of suspicion of others, or we also think, oh, like we compete with other universities. We think, oh, we cannot work with UKM, USM, UPM. They think that you might do better than us. We still have that kind of thinking among some of us. So we don't mind me saying that this is the kisah benar for me. So we need to work together, to trust one another, so that we can really to do well. For example, the papers I did, I did and the USM epidemiology and Kuban and all this, to spend a lot of time to talk to them, to explain to them this collaboration. So with this spirit of working together, and we can achieve more. That's what this team means, right? To achieve more, working together. So it's still a continuing struggle. Not only me, but many people. So collaborating and also trying to understand each other. Really, to do impactful work, the way to do is interdisciplinary research. There's no two way about that. You look at the SDG, the Sustainable Development Goals of the UN, all this require we all work together, scientists, engineers, right? And also the social scientists, policymakers, that only bring about the impact to the society. Okay, Prof.
Yeah, thank you so much, Prof. And with that,
Hope
I
you-
wish everyone good luck, all the best with the whether you're pursuing. And thank you, Prof. And please stay safe, stay healthy. Thank you.
Okay, thank you. Thank you.
Thank you, Prof. Rafiq, for the question and for attending this talk. We appreciate your time. Thank you, Prof. Okay, so now we will move on to the next question. There are so much questions asked in the chat, but Prof would prefer you to actually ask and unmute your mic. Do you think whoever asked in the chat, can you unmute your mic and then ask Prof directly? Okay. Before that, I have some question from the registration. So one question, which is very interesting, Prof. So is it possible for medical physicists to practice overseas? If yes, what are the requirements?
Yes, it is possible. A couple of Malaysians are working overseas. In fact, in Singapore, Arabia, I know one working in UK, a couple in Australia. You need, beside the academic training, at least a master's degree and preferably a solid clinical background. And if you can go for the board certification, for example, I have my American Board of Medical Physics, which is American board certified, but today you have this international certification. You should go for that. It is a value added, and that definitely, and there's a lot of opportunities working overseas, in Asia, in Europe. Okay, to answer your question.
Okay, Prof. Okay, so Dr. Sakina, you would like to ask something just now?
No, tomorrow. Hello.
Good morning, Prof.
Yes.
Good morning, Prof. I actually want to ask something. As one of the question that I always had is, you actually have many collaborators, and like we are working with so many people. And I actually very aspire to also have my own group like everywhere as well. But most of the time at the moment, as someone who's also started a career, so I don't have so much collaborators. I just want to know that how do you actually have this kind of collaboration? How do you I don't know how should I approach next collaborators who can I trust, because being someone who's actually new, I don't really know much like many people. So who's actually I can find someone who really that I can trust and then collaborate with, because sometimes we'll just maybe make use of you sometimes. And then another question that I'm very interested with your mentoring global just now. May I know how do I maybe get involved if I'm interested to get a mentor for myself?
Okay.
And the third question is, as a program, okay, can I ask another question? I'm sorry. As a program chairman myself, I'm just seeing that how can I make the program better so that all the graduates can have enough. Maybe I need some kind of a suggestion. How can I make the students maybe become more competent after their graduates? So maybe some insight from you. Thank you, Prof.
Okay. Thank you. Now, how to get collaborators requires a lot of hard work, a lot of determination. So you attend conferences. Of course, last time is physical. You meet people, we start talking about research, right? You make friends with them, you correspond. Those days we wrote letters, difficult now, or email, approach people. Right? Or when you publish papers, right, you will see you reference the site to work, you can contact them. So some of these are so-called cold call, just like salesmen, they knock on the door of someone they don't know. Okay, but some are through contacts of. So for example, I was with the late John Cameron in Wisconsin. He introduced me to his colleagues, his collaborators, so his friend, and continue with the tradition, right? Through contacts, and you need to be brave. Let's say you approach, even for me, I always approach people to collaborate. If I approach 10 people, maybe 3 or 4 will respond, and that's good. Don't expect all will respond to you. And you raise a good question about some may cheat you, and that is quite true. Though academics, we are supposed to be ethical, some there are also some bad guys amongst us as well who are unethical. Right? We work together, they might steal your idea, they might publish something without your name. So this happening. That explains why I mentioned when Rafiq that I noticed in Malaysian system, the culture, we still don't trust each other enough. Right? We have some suspicion. Right? So that is important. So contact them, right? Write to them, and also sell yourself. Meaning, marketing is important, right? Tell them, oh, you are expertise in this and that. Now, recently, someone from Italy wrote to us. In fact, he wrote to, I think, the Ministry of Education, and then to the universities, and what things are silk study and textile from Italy, looking for collaborators in different aspects in chemistry and engineering. This how, like, sending out open letter. So some responded, whatever. We can do the same. Your second question, what is it? Your second question?
About mentoring, about the mentoring,
Oh,
global
mentoring. Okay, I will send write an email to me. Those of you interested out there, I will send an email to me. You can get an email from the internet, Google, or Ashikin. And when we have a mentoring session, the e-mentoring, we will open to all. So we send out the so here variety it's quite interesting. The last time there's someone talk about conflict resolution. Right? We often have conflict in a group, in a department, in a university, right? In a family too. Right? We argue, we don't get along. So how do we? So that's important, right? For us as well. And then we have one talk about how to write papers, how to publish. Okay? So the mentoring, we have the website as well. You can check the Google, you can find that. The last question.
Another one is, I'm the program chairman for the medical physics program. I just want to know, maybe you can give an insight. How can I actually improve the program better? As you know, that medical physics is, to me, is still like a new, even though like you can say this actually have about 30 years that have groups, but I felt like many people still don't know what is medical physics. I always like having a question what is a medical physics is from a new graduate, and also even someone who's already like a student who already enrolled to the program. So how do I actually like maybe improve the program further with the one that we already have now? Because definitely the syllabus that from the previous are not like, because it was evolved like from 30 years. So how do I make the program more competent so that we can actually prepare the student for the future?
Yeah, we need that medical physics, even for me, I've been around for 30 over years. I'm still encounter almost every day in the hospital. People don't know what are you doing in the hospital. In fact, surprise, we have a COVID center vaccination. I met one of the professors in the science faculty. I said, hey, Prof, what are you doing here in the hospital? Right? They still don't, despite all the publicity. So communicating use of the media is very important. We need to work together. How about you and I and my colleagues and work together? We are running program to publicize, to promote medical physics. And we need to update. I mentioned the challenge to be adaptable. So for example, in my curriculum, we included medical informatics that cover all the way up to AI, but we need to expand that. So it's important. We need to be relevant. So the graduate come up, they need to know today you can't run away from computing. You need to be computing literate. You need to do some coding and all the AI, machine learning. We need to step up on that. And molecular biology, if it's not in your curriculum, it's good to include that. Have more and more lecture hours, expose students to that. We want to stay relevant. Else you come out, right? The oncologists are talking about all the oncogene, talking about all the new form of molecular therapy, molecular imaging. And if we don't understand, we are no longer relevant. We are no longer useful to them, right? Remember, we want to play an important role in the society. So let's work together. We need to interact more. That would be good. We join forces.
Prof, thank
Okay,
you.
Prof.
I will definitely contact you.
Yes, please do so.
Okay. So, Prof, Dr. Sakina is very hardworking program chairman.
Good. I'm glad.
I highly recommend her for you to get to know her lah. She's very hardworking, Prof.
Sure. I think it's to work together, to collaborate. For example, often I receive invitation for review paper to contribute review paper, to contribute book chapters. So yeah, I will invite you all. I will send out an open invitation. So this is a way to get going, right? There are a lot of opportunities now, right? I like to open doors and windows to whoever are committed or interested. That'll be good. Huh? Let's work together. That'll be good.
Okay.
Thank
you, Dr. Sakina. Yeah, it's for people who are maybe you are feeling intimidated by Prof. Just know lah, Prof is very friendly person. We WhatsApp occasionally, and then he even reply my emails at 1 a.m. in the morning lah. So he's very approachable lah. So don't be intimidated. If you are interested to collaborate or anything, you can just contact him through email lah. His email is available. Just Google his name. So anyone else want to ask any questions? So there are questions here in the chat, but I think we would prefer you to talk maybe. So anyone else would like to ask anything to Prof? We still have around 15 minutes.
Dr. Ashikin, I saw Hamam like raising hands. Oh, it's actually, do you want to ask a question?
Okay, wait. Yeah. So this one is Prof, the dossier. Oh, wait. This one is, I think, the dosimetry question. I already forward to you, Prof. Where?
Can you read out? Yeah.
Oh, okay. It's already in the list. What is the trend of future hot area in radiation dosimetry, in your opinion? Is it the real-time dosimetry or maybe passive dosimetry? What do you think?
Both will have their use in clinically. We need both passive and real-time. For example, we also need real-time in intervention radiology. It is very important to have the real-time information, like to dose to the lens and so on. We also need passive dosimetry for places we lack the medical physics expertise or need large-scale sampling. Okay? And there are a lot of exciting things in dosimetry now, right? We have this OSLD and now into this optical. Right? That is an important part. Oh, by the way, Prof. Rafiq is what discipline he's in?
I think optics, is it?
Yeah, we work with him.
Yeah, optics,
Yeah,
engineering.
because they developed this fiber, and we are using it. Like some of my team members working with this group, we publish a couple of papers together. Yeah, on this using this fiber, optical fiber as a dosimetry. Yeah, so that is So work with your VC.
So, okay. Okay, so yeah. So Hamam, if I'm mistaken, yeah, he asked, so the Prof recommendation is to collaborate with the VC. Okay, so the next question, okay, the first question actually. What, Prof? What is it, Prof? You want to say something?
No, it's okay. Just that
Okay.
it'd be good. He has a lot of insight. He's a very good engineer. Yeah, we have my group, right? We started working with him, with his group, still going on in the engineering faculty.
So it's actually
Okay.
as medical physicists, it's actually very good for us to collaborate with the engineers as well, right, Prof?
Oh yeah, always. Yeah. See, I have the advantage when I did a minor major in biomedical engineering, and I also started the biomedical engineering program in University of Malaya with the former VC Prof. Gao Jasmine and Dean. We started that. I've been teaching since then. Yeah, a lot of things in common. They also are working with various imaging modalities and various physiological monitoring. Group them in, work with them.
Okay, Prof. Another question. So since it is now pandemic, so we have for us medical physicists, clinical experience is very important, but due to pandemic, it's very limited for us to actually send students to the clinics to do their practical. So because without clinical experience, it's very difficult for them to become competent when they want to, enter the job later. So your advice, how do we increase the competency in this the current pandemic situation, especially in terms of clinical experience? How to do that?
The clinical experience is a must. There's no two-way about it. There's no substitute. It's unfortunate all of us, not only here in Malaysia, but many other countries are caught up with that. We need to, like QC, we can watch a YouTube, can discuss about, but you need to put the phantom to do the measurement. Hands-on. We can analyze image. Like what we do, like we get a student to measure the contrast from QC image, right? They can do, they can very good, but they must know how to do it clinically. That is the essential skill. Same like doctors, right? They can't learn from book. They need to touch a patient, need to look at the patient, talk to them, right? Look at the sign and symptom. So that is something we have a lot of simulation, a lot of e-learning too, but this cannot substitute for the actual. So we need hope and pray that once there's an opening, relax a bit, we can do as much practical as possible. It is very, very important, right? So
okay.
So
just take the time during the pandemic.
Their employability as well. Yeah, we build up. There might be, no doubt. Even like our student in UM, a lot of projects are computer based, right? We do a lot AI project, computer analysis, but they still need the clinical competency. Else they can't work in a hospital. They need to do treatment planning, right? They need to do QC. These are the bread and butter of physicists.
Yeah.
So this will impact the employability. It's unfortunate. That's why a lot of graduates, they are very stressed, I'm sure, right? Okay, even though I get a degree, get my good master, but how to find a job, and also not many openings now because of the pandemic. So it is very good that we can encourage. Meanwhile, Oh, by the way, there are a lot of courses free by IAEA. Really good. Huh? At the end, you receive a certificate, like on cities, on dosimetry. Okay, you spend I think 2-3 hours going through. There's some quiz, and then interactive. So meanwhile, just try to improve on your knowledge and whatever you can learn. The IAEA one is
Okay,
very
Prof.
good.
Okay, Prof. So, what else? So, anyone else want to ask questions to Prof? We have around 10 more minutes. Anyone else? Okay, so some of the questions from the list. Okay, Dr. Sakina, it's okay. Dr. Sakina, proceed.
I actually I just want to check on the Cornelia question, because here in USM we have medical physics undergraduates and also the medical physics for the postgraduates. So maybe most of the undergraduate students don't really know what they have to do next after they have finished their undergraduates. So maybe and also I actually have received a lot of questions from the student. They ask why they have to learn a lot of physics. Because when they choose a course, the name of the course is a medical physics. So they often thought that it's like you will learn a lot of medical, which is a bio. But when I come to here, School of Physics, you basically learn at least 50% physics, not the medical itself. So some of that even questioning why they have to learn physics. So perhaps, Prof, maybe you can give an insight what are the importance of the physics, and then what the undergraduate, maybe if they're really interested with the medical physicist as their career, so what they have to do next after they finish their undergraduates.
Physics is the fundamental knowledge. You really can't call yourself a medical physicist. First of all, you are a physicist, right? You can have a laser physicist, you have a plasma physicist, isn't it? So, but you are a medical physicist, means you are a physicist, but you work in the medical setting, right? So the physicist is a core. Just like you're a chemist, you're organic chemist. You're a chemist, you need to know chemistry, but your field is specialized in organic chemistry. Without the fundamental physics, example, I think I highlighted like quantum mechanics. It is important. Oh, so abstract, but it's useful to really, you want to, let's say, understand MRI. You want to make a contribution to do all this, the lot of new techniques in MRI. You need to know your physics well. And particularly now, all these proton therapies coming, heavy ion, even PETs, the positron emission tomography. You need the physics, you need solid physics to understand. Else, how are you going to work or explain to the radiologists, oncologists, or the technologists or radiographers? Right? The technologists will ask you, they look up to the physicists. Can you explain how this works? Why this artifact? Can you change the noise? So the physics will come in handy. It's important. So you need to increase from 50% maybe to more and more. As technology advances, we need that the physics. When I say physics, the fundamental physics along with these mathematical techniques. So the maths, the stats are important. Like move to AI, we just don't use a CAN software to do, oh, this is what I'm doing, but you need to go to understand that. Right? That will differentiate what is the medical physicist. At the beginning, I mentioned we are both, we are a profession and a science, right? So we are scientists. By the fact that we are scientists, but if we work in the healthcare, we are also a profession. We are clinical physicists. So along the way, we need to know basic anatomy. The medical staff will bring it in. What a good analogy is medical doctor. To be a surgeon, you need to have the doctor first, isn't it? You need to have MBBS first. No exception, right? You can't say, oh, I learned, I just want to be a surgeon. I don't want to learn internal medicine. You can't. You need to learn the basic 5 years medical school first, everything, right? The good foundation in medicine to be a doctor, or a general doctor. Then you specialize to be an ONG, to do a surgeon, oncologist, right? The further. So I use the same analogy. We need to have a strong foundation in physics, and this is where we will use the knowledge to advance the field, to understand, to improve, to educate our colleagues, doctors, nurses, technologists. So that is important. The physics as the core. Hope this explanation will help the students. If, for example, right, you don't want to pursue this, you just want to be a technical level, like you can be a radiographers, right, who know some physics, but their work is more technical, routine, right? Set of the patient, precision, time to take X-ray, CT scan. They also play an important role, but there it's not that scientifically orientated. It's more, you were interested in more patient clinically, like doing ultrasound or CT scan, MRI. That is a good alternative, right? I know some students, they just have no feeling for physics or maths, or we don't want to think too much. They prefer the more routine clinical work, then take up the radiography or technology. That is equally important, right? We need a team. So they're different. It's up to your interest, your commitment, and what your dreams are.
Okay, Prof. I think I would go to the last questions lah. Okay. So as a lecturer, like as a lecturer, so how we have a very high commitment. Like we have teaching load, we have research, we have undergraduates and postgraduates supervision that we have to do aside from family and kids. So can you share your tips? How do you prioritize your all of these things lah, multitasking and can you share with us?
In my early career, I spent time in self-improvement. I took courses on my own. Maybe I can persuade, maybe I talk to VC personally later. Time management is important. I took up courses on those time management. It helps a lot. I remember those. We need, because all of us trained as scientists, right? We are never trained to develop our soft skill, leadership skill, time management. So that is important. Of course, the priority will be definitely to our family, very important. Our family, ourselves, our health, all this is important. Right? It is demanding now. In fact, I don't envy your younger generation. So much pressure. My time, I didn't have the KPI. I didn't have all this armored paper. We just pursue our interests as academic. We teach, we get students. But now you have how many papers a year, all this KPI pressure. Okay, that's we didn't have in our time. So it is difficult. I sympathize with all of you. You have a lot of administrative work, teaching, and your own family, and all that commitment. But just do your best, right? Have a balance is important, and collaborate is important. Work with each other. So just like in publications, you collaborate more people together, you can have a better and greater output in terms of number of publications. Things. So always do things together. I always emphasize. I didn't really understand. I'm very much a team player. I always get team player. Even the students, I get them to work together. We go out lunch together. We do things together, and that in a way will help a lot to support each other. Maybe one day we can have a forum, we can discuss some of these points, and I can organize one with you all. It'd be a good idea, right? Bring someone from this guy on management, time management, then we can share our experience.
Honestly, I would love to, Prof, because
Good.
yeah, I would say that having the balance itself between work and then the family is it's not easy. I would sometimes like realize throughout the day I only maybe interact with my son because we are working from home, but I definitely like just sitting in front of my laptop doing work, and then sometimes you have classes, workshops as well. I think that I'm just interact with the okay, you want to eat, and then that's it. Even after that, still have like prepare to classes. So even at night time, I have to be in front of my laptop. So especially in this during this COVID-19 as well. So it's very good if we can have like a session. How do we balance
Yeah, we just share. But
work
can I,
in the career
yeah,
and the family? Yeah.
yeah. Can I take opportunity? I think some of you listening in will be non-medical physicists from, say, maths, management, might be art, social science, or engineering. So hope you benefit a little bit from this talk, and I hope that we look out for opportunities we can work together. There are definitely a lot of opportunities out there, right? We can collaborate and be very innovative, right? We can open up new areas. We can contribute in a small way to the well-being, right? In fact, through this COVID pandemic experience, we realized that a lot of things we can come together, put our heads together to do a lot of very interesting things.
Dr. Sakina, do you have anything else to say before we wrap up? I think we shall wrap up soon. It's already 11:30. So Dr. Sakina,
I just want to thank Prof. Thank you so much for at least like sharing. Honestly, it's very inspiring. I actually feels like almost tearing up listening to your talk with so much wisdom. Yeah, because it's really touches my heart with your words. You know, especially the integrity and then the like being
Yeah,
grateful with the things that we do. Yeah, and
yeah,
honestly, I'm very grateful for having you today. Thank you so
yeah.
much.
Thank you, Dr.
We definitely will receive a
Sakina.
lot more invitations from us.
Yeah, thank you. Yeah, be good. Yeah.
what I will say, Prof, if Dr. Sakina is your student, I think you would be happy to have her if she was your PhD student. She's I think she's much more like you. She likes to draw. She even give us some drawings and collage for our Ramadan, and then she likes baking as well. She just recently started baking.
Yeah,
I think you would like her if you get to know her.
yeah. I mentioned baking in towards the end. I didn't know. Yeah, we can work together, no problem. I work very fast, then no one will know me, right? I don't procrastinate.
Yeah.
So we can start some collaboration with Shakina and the others as well. No problem at all. Okay.
Okay.
So thank you very much for all of you.
Okay. So if nothing else, I think we shall wrap up the meeting. So for those USM, okay. That's again.
Can we have a photo session together? Sorry. Can we have a photo session together?
Yeah. Okay.
Session, yeah.
But there's a lot of attendees. How do we capture everyone in one screen?
Have to keep on like next. Maybe like pre-screen.
Oh, okay.
I can do.
So Dr. Sakina, can you do it for us? So just a reminder for all of you USM student and staff, please fill in the form that Dr. Sakina gave. So because there's some problem with my feedback form, just fill in the form that Dr. Sakina gave to claim your my CPD and my CSD form. So hopefully this is useful. So I will try to share the recording to the email of the attendees later for your reference. So I appreciate your time and your commitment in attending this talk. Hope it is useful. So can we have the photo, Dr. Sakina? If you would like to open your video.
I'm waiting for for anyone else. Can you on your video? Maybe I should wait for a few more others.
Okay. So for those who without your scarf, just cover with anything. Maybe a towel. Quickly.
Anyone else? Come here. I can see more and more. I should wait for a while.
Maybe we can.
Okay, I'll take the first page first. Okay, ready? 1, 2, 3. Okay, wait.
More coming.
Yeah, more coming. That's all. I think they need sometimes.
They need their
Okay,
scarf.
1,
Towel.
2. Yeah, 1, 2, 3. You can see more and more.
How do you move to next page?
There is actually have like a next button. There. Okay, ready? 1, 2, 3. Okay, now let me go to next page. You can see more. Okay, next page. 1, 2, 3. Okay, another one. 1, 2. When I move in, it takes some time for the image to come out. Okay, 1, 2, 3. All right, I'm done.
Okay. So thank you everyone.
Done, Dr.
Okay. So Prof, there's a lot of thank you notes in the chat for you to see first before we.
Oh, can you copy
before
the chat? I like to look at it. Can you copy
Okay,
the
Prof.
messages in the pad and send it to me?
Okay, Prof.
I think I
So
can
thank
save
you
it.
everyone for attending. Make sure you have fill in the MyCLSD and MyCPD form for your SEM student and staff. And with that, I thank you and hope this inspire you to become a better researcher or students in medical physics or maybe in other field. So thank you. I see you guys maybe later.
Okay, thank
Okay,
you.
Prof,
Bye-bye.
I will screenshot I will copy the text later.
Okay, thank you very much. Okay. Thank you, all of you. Okay.
Thank you, Prof. It's
Thank you.
very interesting, very
Yeah.
interesting talk.
What is interesting, the VC attended the talk. Very
Yeah,
honored.
I didn't expect he would. I didn't
Huh?
expect he would stay until the end of your talk. Actually.
For VC. In fact, I had brief encounter with him. Yeah, we started this project on this optical fiber as a dosimeter. And Dr. Vincent Ong have a student working him. He got a couple. We work together. So it's a good example. Because when you have the fiber, they are doing all the electrical, all the properties. We apply it. It's a good example of working together. And the optical is a passive detector, but how to turn it into an active, that is ongoing research.
The engineers do that.
Yeah, we need way
Yeah, we need to
to
collaborate.
read out the data. Electronic to read out the data.
Okay, Prof, I'm copying the
Okay. So
comments.
I leave the meeting now. Okay.
Okay, Prof.
Okay. Thank you very much once again.
Okay, thank you, Prof. See you again.
Okay. Bye bye. Take care. Okay.
Thank you, Dr. Hashikin, for organizing this.
Okay. Thank you, Dr. Sakina.
Thank you. Now, where is it?
Click the X button, Prof.
Which button? X.
The X red button.
The red color one, is it?
Yes.
No, it doesn't work. I click. Oh, I see. They'll ask you to confirm. After I didn't see.
Thank you, everyone.